In computer networking, the term topology refers to how a network is structured. However, a network doesn't exist solely in physical space, it also functions through data flows. Therefore, we divide this concept into two pillars: physical topology and logical topology. 1. Physical topology. Physical topology is the actual and visible arrangement of cables and devices, such as switches and routers and computers on the network. Main physical models. Star. This is the most widely used model today, both in wired and Wi-Fi networks. All devices are individually connected to a central point, such as a switch or router. Advantage. If one cable breaks, only that computer loses the connection. Disadvantage. If the central point fails, the entire network collapses. Bus. All nodes are connected to a single continuous central cable, which has terminators at the ends. Today it is obsolete, formerly used with coaxial cables. Advantage. Simple to install and use little cable. Disadvantage. If the central cable breaks at any point, the entire network stops working. Ring. The devices are connected in series, forming a closed circuit, a ring. Each computer receives the signal and retransmits it to the next. Advantage. There are no data collisions, as the signal travels in only one direction. Disadvantage. If a single machine fails or the cable breaks, the entire network is interrupted. Mesh. Each device is directly connected to multiple or all other devices on the network, partial or full mesh, widely used in WANs, such as the Internet, and mission-critical systems. Advantage. Extremely high redundancy and fault tolerance. If one path fails, the die follows another. Disadvantage. Extremely high cost and complex wiring. Tree. A variation of the star topology, where multiple star networks are interconnected in a hierarchical structure, usually linking secondary switches to a central backbone switch. 2. Logical topology. Logical topology refers to the way data travels through physical circuits, that is, how signals are transmitted from one device to another, regardless of how they are physically connected. Even though the network visually resembles a star, logically it can function as a bus or a ring. Main logical models. Broadcast. A device sends its data to the physical medium, and all other machines on the network receive this information. The data is only processed by the machine that has the corresponding destination address, such as the correct MAC address. Practical example: modern Ethernet networks logically work like this. Physically, they are organized in a star configuration, cables connected to a switch. But logically, the data uses the Ethernet protocol to manage transmission traffic. Token passing. Network access is controlled by an electronic signal called a token. Only the machine that currently possesses the token is allowed to transmit data. When finished, it passes the token to the next computer. Practical example: old token ring networks or FDDI fiber optic networks. Physically, they could even use a central concentrator, resembling a star, but logically the signal traveled in a circle, ring.